All right, we're working today on Chapter 2. Chapter 2, we're just going to do sections 2.1 through 2.4. Just kind of FYI. We'll kind of come back a little bit to 2.5, 2.6 later on in the chapter or in the unit. But for right now, I just want you to know sections 2.1, 2.2, 2.3, 2.4. So we're going to start off with, this whole thing starts off with domain and range. And this is actually where you're going to start when you get into pre-calculus. The first part of pre-calculus is domain and range. Big part of many higher level math courses. Domain. What you need to know about domain is domain are the x values. It's the possible x values is what I want you to know. Possible x values. And then the range are the possible y values. Okay, domain is the x values, range is the y values. So in this set of numbers, what is the domain? Well, in this set of numbers, it's the set of the x numbers, the 5, the -3, the 1, and the 7. That would be my domain, that set of numbers. The range is the y values, and I remember this. One way I remember it is D comes before R in the alphabet, X comes before Y in the alphabet. So my range goes to my y, and it's the y values, the 6, the 0, the 6, and the -9. Oops, sorry, I should do my little thing. Is this a function? Well, to think about is it a function, the answer is actually yes. And what you're looking for is you're looking for, are there repeated x's? All right, in other words, for it to be a function, every x, which is considered our input, what we kind of usually put in and have values in for our equation, is there exactly one output? Okay, so if I were to add the value 5 comma -9, or say -19, let's do it that way, then my answer would have been a no, because the 5 can't go to the 6 as a y value and to the -19 as a y value. So that answer would be nope, it's not a function. But as long as what we have here doesn't have any x's going to different y's, we're fine. All right, so no repeated x's would be my reasoning for y. All right. Vertical line test. Well, that's another way to see, do I have more than one x? Okay, or do I have an x going to two y's is a better way to do it. So the way I can do this, and I know this is kind of a small graph, but if I drew straight lines here, if I only cross this graph, this curved graph, in exactly one spot, and let me show you again where this curved graph is. Here is the curved graph right here over top of it. It's only those red lines, those vertical lines are only touch it in one spot. If you can only touch it in one spot, then yes, it is a function. All right. If I had an example that like this, an ellipse, okay, now when I draw my vertical line, it touches in two spots. Then your answer here would be no, it's not a function. All right, because you can't have this value here has a value up here and here. So it fails the vertical line test, not a function. Sorry, I was writing and talking. So now we're going to evaluate some things. It says, okay, we have a function, and this is our function notation. F of x is how you say this part right here. F of x equals x squared minus 3x plus 12. And what this is saying is, it's saying please substitute -4 in for x. All right, you usually don't use please in mathematics, but that's what it's basically saying. So to solve that, we would say, well then f of -4 equals -4 squared. So for this x, I substituted in the -4 minus 3 times -4 plus 12. Okay, -4 squared is 16. -3 times the -4 is positive 12. And then we have positive 12 here. Okay, so 12 and 12 is 24, plus the 16 is 30, 40. So our answer here is 40. Now let's look over here. So we're going to do the same problem, g of 5. 4 times 5, and then 2 times the 5 plus 7. My numerator would be 20. My denominator is 17, because 2 times 5 is 10 plus the 7. That would be my answer. That's what g of 5 is. All right, now we have to match the slopes to the type of line. All right. Well, let's talk about these three types of lines. In order to have perpendicular lines, their slopes are reciprocals. And they have to be opposite sign. One has to be positive, one has to be negative. Okay? Let's look at parallel. In order to be parallel, you have to have identical slopes. And then anything that doesn't fit into these two categories fit into the neither category. So now I'm looking at my slopes here, 1 and 2. Reciprocals would mean that if I flipped the fraction, would it equal the other fraction? All right, and this one, in this case, it's no. Are they identical? The answer here is no. So 10 is it's a neither. Okay, and let's look at 11. Slope is 1 and slope is 2. Oh, I messed. Slope. Oh, sorry. I saw slope 1, 2. Never mind, guys. Just made a mistake in reading. Here, I'm just realizing that the slope is 5 for each. Hey, those are identical. This is identical, or parallel lines, because the slope is identical. Here, the slope is 1/9 and -9. So 1 over 9 is the reciprocal of that, 9 over 1. Yep, it is. Is 1 positive and 1 negative? Yep, it is. So it's kind of has the two possibilities, two things we need for it to be perpendicular. Now here we have a slope of 14 and a slope of a -14. One's positive, one's negative, but the flip reciprocal is not the other one. So if this one was flipped around, it would not equal that. So this one is our neither. Sorry about my mistake, guys. Find the equation of a line that has a slope of 8 and a y-intercept of 15. Well, we've worked with this before. We're going to work with our lines in slope-intercept form, and hopefully this is review. Where this right here is we've talked about it before, it's our starter, which in our cases when we're graphing is our y-intercept. It's what is y when x is 0. This one is known as our slope, or the change in y over the change in x. So for us, we need to just put in our 8 for the slope and our 15 for the y-intercept. Now find the equation of the line that passes through this point and it has a slope of 2/3. So what we know is we know this. It would be y equals 2/3 x, but we don't know plus what? We don't know where that starting point is. So you either have to use some logic or you kind of have to do some calculation to figure this out. We're kind of asking ourselves, what is our b? All right, so that's our big question. One way to figure out our b is we can say, well, we're given some information. We know that point works. So when y is 7, and remember when we're given an ordered pair, we're given it in x, y values, and when x is 9, 2/3 times 9, this all works. It all is a balanced equation. So there's some number here that you'd add to this to make it balanced. Okay? So let's try to figure out what that number is. 2/3 of 9. I'm thinking of this in my head. Remember, this is like multiplied by 2 divided by 3. 9 times 2 is 18, divided by 3 is 6. So we have fractions, we can just think of it as multiplied by the numerator, divided by the denominator. 6 plus what magical value b equals 7? Well, 6 plus 1 equals 7. Therefore, my b here had to have been 1, that this will be what it always works. So my answer here in the end is that y equals 2/3 x plus 1. That is my equation of this line. And now we have an equation of a line here where it goes through two different points. Well, first we need to find our slope. All right, it's easier when we think about what is the slope to begin with. Now, if you remember, the slope is the change in y over the change in x. Y changes, it goes from 1 to -5. So figure out how it changes, you're going to take your second y value and subtract your first y value. The x changes, it goes from -3 to -6. So I'm going to go and take my second x value and subtract away my first x value. Here I get a -6, and then this here would be plus, so it would be divided by a -3. Answer here is a 2. So what we know now is that my slope is a 2, and both of these points work. Well, I can do what we did up here. I can say, well, I know this much. Y equals 2x, and I'm missing some value b. All right, positive or negative. I guess I don't know why I would put the positive there. So I'm missing with some b. All right, well, we have to calculate what the b could be. So I know that the point when y is 1, x is -3 works. But I have to know it works or it balances by adding some unknown value of this b. So 1 would equal -6 plus what? All right, well, only -6 plus a +7 equals the 1. So I know, and I can kind of figure it out, this has to be a +7. Oh, b has to be a +7. I could also have solved this for b here. So now I know this is really a +7. Let me write it a little prettier for you. Y equals 2x plus 7. My final answer. All right, find the equation of a line that passes through a point and is perpendicular to y equals 5x plus 7. Well, they actually give me a lot of information when they say perpendicular here. If you remember, perpendicular slopes are opposite signs and they are inverses. So knowing that, I can figure my new slope, my new m, has to be the flip of this m. All right, so flip of that. So the flip of 5 over 1 is 1 over 5. And it has to be, this is a positive, so this one has to be negative. So my slope here is, we're going to be at y equals -1/5 x. And we have to add some unknown b. All right, we have to figure out what that is. Now, a lot of students will make this mistake. They'll be like, well, the b has to be 7. It was b in that one, so it has to be b the same b. No, not necessarily. What we have to use here is this point. We know the fact that the y, when the y is 3 and the x is a -5, it works out with some magical b here. This right here, -1/5 times 5 would be a +1. 3 equals 1 plus what? Well, b must be a 2. We can replace this b with a 2. So my equation, this would be a 2. We have our equation here. So you can see here we have our answer. So now I just gave you the answers already, some of the problems here, kind of review problems. So what I'm looking at 5, we're trying to find the slope. I took the change in y's and I divided it by the change in x's. You can see I took the second y minus the first y, the second x minus the first x in the denominator. Reduced it down to a fraction, 2 over -8. That reduces to the fraction -1/4. Same process in number 6. Now in number 7, they're asking me, are they parallel, perpendicular, or neither? Well, I calculated the slope for each. Again, using the same process I used in 5 and 6. When I figured out that, hey, these match, they're the same, well, same slope, same m, means it leads to the idea that they must be parallel. Oh, my writing is not great, but we'll deal. All right, so then in the next section, all right, we just had some multiple choice questions here. Is it parallel, perpendicular, or neither? And we kind of had an example of either, and I'm really just basing it all on our slope. Remember, in perpendicular, we're looking at reciprocals. If I put it as a fraction, are they the flip of each other? And just having them opposite signs is not enough, and that's what 10 is telling us. You have to have the reciprocal. I think I have time for this one. All right, we have a flat rate. We have an equation here. And we want to know, okay, what's the flat rate? Flat rate means you don't get a choice. All right, you don't get a choice on, you pay 35 bucks every month. All right, that's one of the costs. And then what you get a choice on, or what changes, is how many premium channels you want in the month. That's what you have a variable. All right, so what's the per premium channel fee? That's the $15 that you pay for every premium channel. So that's in addition to what doesn't change. In other words, it doesn't have an equation. So that's kind of like, just again, looking at that. What does it mean when we have slope, and what does it mean when we have y-intercept? In 12, find the equation of line. We have a slope and a y-intercept of 15. We started with a problem like this, and the answer is y equals 8x plus 15. That's what we get for that problem. And we'll look for the next video for the rest of these questions.